The Tiger I tank was an iconic and formidable machine of World War II. However, its rushed design meant there were many areas for improvement. If German engineers had the benefit of hindsight and more time, these 5 changes could have made the Tiger I a more effective and reliable tank from the start. Simplifying the Tiger I's suspension was a practical and realistic option. The original tank used an elaborate system of interleaved 24 road wheels on each side. This setup gave the Tiger excellent ride comfort and spread its heavy weight across the ground, but it came at a steep cost. Building and maintaining Tiger I's suspension were slow, expensive, and notoriously difficult, especially in muddy or frozen conditions. A simpler suspension could have been adopted with little new research, relying on proven technology already in use on other German tanks. The biggest benefits would have been in production and upkeep. By reducing the number of wheels and parts, factories could have assembled Tigers faster and at lower cost. In practice, this would have meant noticeably more tanks rolling off the production line. Maintenance in the field would also have been far easier. Replacing a wheel, which often took hours under the historical system, could have been done in about an hour with a simplified layout. This would have kept more tanks operational in harsh weather, improving overall readiness. Fewer unique parts would have eased supply chains and allowed for interchangeability with other German vehicles, while mechanics would have needed less training to keep them running. Even a small reduction in weight, though minor, would have aided mobility. The trade-offs were mostly in ride quality and off-road ability. Crews would have felt more jolts during long marches, leading to greater fatigue. The tank's weight would have been spread less evenly across the ground, making it a little less effective on soft terrain. Speed in rough country might also have dropped slightly, though road performance would remain largely unchanged. Simplifying the suspension would have greatly boosted Tiger production, reliability, and battlefield availability, which far outweighed the little losses in comfort and mobility. Improving the Tiger I's turret traverse was both realistic and highly beneficial. Historically, the Tiger's hydraulic system turned the turret very slowly, painfully so in combat. At low engine speeds, it could take a full minute for a complete rotation, and even under ideal conditions, it was far slower than Allied tanks. A stronger hydraulic drive could have been fitted without new inventions, simply by giving more design priority to speed. This would have allowed the Tiger's turret to rotate in just over 10 seconds, giving it among the fastest traverse of any tank in the war. A quicker traverse would have transformed the Tiger's battlefield performance. The most obvious gain was reaction speed. When an enemy appeared on the flank, the Tiger could bring its gun on target several seconds faster. In close quarters fighting, such as in towns or forests, this advantage would become even more decisive. It also meant the Tiger no longer had to rev its engine to rotate the turret, which saved fuel and reduced wear on the power plant. The costs and penalties were minor, as a slightly heavier or more complex hydraulic unit would have barely affected the Tiger's overall weight or price. And while it might have added some strain to maintenance, the trade-off was small compared to the gains. A faster turret traverse would have made the Tiger I deadlier, more efficient, and significantly harder to outmaneuver, all for a negligible increase in cost and complexity. Improving the Tiger I's crew ergonomics was both simple and realistic. Post-war testing often described the tank as cramped and uncomfortable, and these issues were not structural but design choices. The Tiger carried a crew of 5, so the space was tight, with its low turret headroom and narrow escape hatches. These flaws could have been addressed with minor adjustments, such as better seating, improved hatch placement, and rearranged interior fittings. The benefits of improved ergonomics would have been considerable. Faster evacuation from the tank could have saved precious seconds in emergencies, which raised crew survival chances during catastrophic hits. Redesigning seats and controls would have eased strain on gunners and loaders, reduced fatigue over long operations, and allowed the loader to cycle shells faster. A more efficient ammunition layout could have slightly increased the tank's rate of fire, enough to give a vital edge in combat. For commanders, better seating and periscope design would have made scanning the battlefield quicker and less tiring. Drivers and radio operators would have worked more effectively with improved controls and equipment placement. Even simple additions like padding and shock dampeners could have lowered the risk of minor injuries from constant jolts. The downsides were minimal. Additional padding, larger hatches, or reconfigured layouts would have added little weight and only minor production delays. Costs would have been negligible compared to the benefits. Better ergonomics would have increased efficiency, survivability, and crew endurance at almost no cost. These small design improvements could have made the Tiger I not only a formidable machine, but also a more sustainable one for its crews. Adding sloped armor to the Tiger I was within the realm of possibility, but it would have required a full redesign. The tank's original layout relied on thick, flat plates that were simpler to manufacture, but heavy. Switching to angled armor would demand new geometry, new welding techniques, and extensive factory retooling. Given that the Tiger was already one of the most complex and time-consuming tanks to build, this change would have delayed its entry into service by many months. The appeal of sloped armor lay in its efficiency. By angling plates, the same thickness of steel could provide far greater protection, forcing many incoming rounds to deflect rather than penetrate. Against allied more powerful anti-tank weapons, this could have turned some otherwise fatal encounters into survivable ones. In theory, thinner, angled plates could also reduce the vehicle's weight, slightly improving speed and easing the burden on the already strained suspension and engine. The downsides were equally significant. Manufacturing sloped plates was more complex and time-consuming, raising costs and stretching German industry even further. Angled armor also reduced interior space, worsening crew comfort and leaving less room for ammunition. To compensate, designers might have enlarged the hull, which would cancel any weight savings and possibly make the Tiger even heavier. Most importantly, the time lost to re-engineering and retooling could have meant fewer Tigers produced during the decisive years of 1942-1943. The result would likely have been mixed. A sloped armored Tiger would have been more survivable in combat, reducing losses to frontal fire. Yet fewer tanks might have been available at critical moments, weakening overall German armored strength. In this sense, the upgrade offered greater quality, but at the cost of quantity. The Tiger I's final drive was one of its weakest points. The heavy tank and its powerful Maybach engine put extreme strain on the drivetrain, often leading to breakdowns that immobilized the tank. Repairs were difficult, sometimes requiring the turret to be removed to access the front-mounted drives. A stronger design using improved gears, better bearings, and reinforced housings was possible, but it would have needed several months of engineering and testing before mass production. A more durable final drive would have greatly improved reliability. Breakdowns could have been cut in half, raising the percentage of combat-ready Tigers and reducing the constant need for recovery vehicles. Units in the field would have maintained a steadier tempo, with fewer tanks sidelined by mechanical failure. In practice, this meant more tanks available for combat when it mattered most. A redesigned, modular final drive could also shorten repairs from days to hours, making field maintenance far easier. Secondary benefits would include less damage to the transmission, which further boosted service life. The downsides would be small. Slightly heavier and more expensive parts added little to overall weight or cost. The main drawback was development time, months of redesign and testing that could have delayed early production. Yet a stronger final drive would have been a major gain in reliability and combat availability, with only minor trade-offs in cost and schedule. A redesigned Tiger with sloped armor, simplified suspension, stronger final drives, faster turret traverse, and better crew ergonomics would have shifted from brute force to a more balanced design. The result would be a more reliable, agile, and lethal tank, with fewer breakdowns, higher availability, and greater battlefield impact than historical Tigers. Thank you for watching, and see you in our next videos.